Hello student, welcome to chemistry class. Today we will discuss about acid and alkali. At the end of this meeting, you will do a quiz. Okay, now introduction to acid and base. Acid, any substance that in water solution tastes sour. Vinegar, lemon juice, and grapefruit are all sour tasting because of the presence of acids. These acids are present in animal and plant material and are known as organic acids. A mineral acid or inorganic acid is any acid derived from any inorganic compounds that dissociated to produce hydrogen ions or H+ in water. Mineral acids are highly soluble in water but tend to be insoluble in organic solvent. The inorganic acids are corrosive. Okay. Below are some common acids. As ethanoic acid, we can find it in vinegar. Methanoic acid, we can find it in ant and nettle sting. Lactic acid, we can find in sour milk. And citric acid, we can find in lemons, orange, and other citrus fruits. But mineral acids, you can find it in carbonic acid, in fizzy soft drinks, and hydrochloric acid you can find we use it to clean metal surface, or you can find it in gastric acid in your stomach. Nitric acid used making fertilizers, and sulfuric acid you can find it in car batteries. Phosphoric acid you can find it in making fertilizers. Now, indicator. Okay. Certain colored substance, many extract from plant, has been found to change color if added to an acid solution. This color change is reserved if the acid is cancelled out or neutralized. Substances that do this are known as indicator. There are many kinds of acid and alkali indicators. The commonly indicators that often used in chemistry laboratory are litmus solution or paper, liquid indicator, and universal indicator. So, litmus. Litmus is purple in neutral solution. When added to an acidic solution, it turns red. This color change of litmus needs chemical reactions. The molecule of indicator are actually changed in the presence of the acids. It will turn to blue if litmus solution put into alkalis. So this is the example, this is the picture of the solution when put into the acid and litmus, and this is base solution, and we put it litmus, so it changed to blue. Next, litmus paper. This paper has been soaked in litmus solution. It comes in blue and red form. The blue form of litmus paper changes color to red when dipped into acid solution. Red litmus paper turns to blue in alkali solution. Note that litmus just gives single color change. This picture is the example that litmus paper put into base solution. The red litmus put into the base solution, it turns to blue. And blue litmus put into the acid solution, it turned to red. It turned to blue, it turned to red. Litmus paper cannot measure the value of pH, but it only can determine the characteristic, the properties of solution, that is acid or base. Liquid indicator. Liquid others indicator that have been frequently used are phenolphthalein, or we know it as PP, phenolphthalein, and methyl orange, and we know it as MO. They give different color changes from litmus. These changes are sometimes easier to see than litmus. For example, this is blue litmus, this is red litmus. In acid solution, it turns to red, and in alkaline solution, it turns to blue. And methyl orange, in acid solution, it turns to pink, and alkaline solution, it turns to yellow. And methyl red, in acid solution, it turns to red, and in alkaline solution, it turns to yellow. And phenolphthalein, or PP, in acid solution, it has colorless, and in alkaline solution, it's pink. Indicator universal. Universal indicator or full range indicator is a mixture of indicator dyes. The idea of a universal indicator mixture is to imitate the color of rainbow when measuring acidity. Such an indicator is useful because it gives a range of color or spectrum depend on the strength of the acid and alkali added. When you use universal indicator, you see that solution of different acids produce different color. Indeed, solution of the same acid with different concentration also will give different colors. For example, we have the different acids and the same concentration. For example, we have hydrochloric acid 1.0 m, and we have ethanoic acid 0.1 m. Because hydrochloric acid is strong acid, so it will give bright red color when a universal indicator put into this solution. But for ethanoic acid, because it's weak acid, so the color going to orange to yellow. So this is for HCl 0.1 m, and this is for ethanoic acid with the same concentration. But when we have the same acid, for example hydrochloric acid, but different concentration, that is 0.1 m and 0.0001 m, it will give different color of universal indicator. The highest concentration will give bright red color. It means more acid. The highest concentration will give bright red color. It means that it's more acid. But the hydrochloric acid with concentration 1 times to 10 to the power of 4. So it's a lower concentration than this hydrochloric acid. So it will give color to orange and yellow color. It means that it weak. No, not weak. It means less acid. So this is the same way with the base. So more red means more acid, and more purple, more alkaline. Okay, this is the looks of universal indicator. This is the stick before you put it into the solution, and if it changes to this color, so it means it has a 0 pH, 1 pH, 2 pH, and so on. Okay, the scale of pH. Rule of the pH scale. 1. Acid has the pH less than 7. 2. The more acidic a solution, the lower the pH. Natural substance such as pure water have pH of 7. Alkali have pH greater than 7. The more alkali solution, the higher the pH. Next, so this is the range of the pH from 0 to 14, and it examples in our daily life. The lower pH, more acidic. The higher pH, more basic. And the neutral pH is 7. Okay, this is the question, and you have to answer it in Google Classroom and in Google Form.